Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 181. The very first problem on the page 181, problem number 203. I'm going to read it to you very quickly. It says a store currently charges the same price for each of the towels that it sells. If the current price of each towel were to be increased by $1, if the current price were to go up by $1, we are told 10 fewer towels can be bought for $120. 10 fewer towels can be purchased for the $120. Question simply is, what is the current price of the towel? So we're going to pretend that the current price of the towel is P dollars. We're going to pretend that for $120 we can buy N number of towels. N is the number of towels that we can buy right now before the price increase. And therefore, the number of towel purchased times the current price is $120. Now listen, there are two ways we can actually go about solving this thing. I just realized. One is what I call the traditional way, the orthodox way, the classical way, the conventional way, the academic way, the algebraic way, the mathematical way, the proper way, the way the exam writer expects you to solve this problem. Which is fine if you can handle the algebra, if you can brook it, if you can tolerate it, which is fine, great. Kudos for you. But what I have found through experience is that even if you're very good at algebra, doing it algebraically, especially a problem like this, which are a little bit complicated, a fairly complicated algebra problem, it's not something most people can handle in a matter of 2 minutes. And you're more likely to make mistakes. You're more likely making mistakes is not a point here. You might also make a mistake in the other method, but when you do it conventional way, the mistakes that you might make are very predictable. And if you end up making 4 of the most popular mistakes, if you end up making one of the 4 of the most popular mistakes, then your answer that you arrive at is going to be one of the answer choices in the book, in the exam, and you will never know that you got the wrong answer. They give you 5 answer choices, one of them of course is the right answer. The other 4 answers do not just fall from the sky, they're not just put there arbitrarily. They are the 4 most popular mistakes people will make when they solve the problem in a manner that they are expected to solve. Don't do it that way. The second method is here. Here's the second method. Now the method that I'm describing here only applies when the answer choices are numeric. When the answer choices are numeric, use a technique called back solving. In the back solving technique, what you're doing is that, for example, listen, I'm gonna make up a problem. I'm gonna make up a different problem, and I'm gonna give you the answer choices. Okay, we're gonna keep this problem right now in abeyance. We're gonna keep it in abeyance right now. We're gonna work on another problem, and I'm gonna give you answer choices. Okay, listen very carefully. Mumbo jumbo, mumbo jumbo, mumbo jumbo. How old is Mike? How old is Mike? That's the question. Whatever in the beginning, the part that it gave you, that was the problem, the mumbo jumbo part. The punchline is, how old is Michael? And here are the answer choices: 10, 12, 15, 20, and 25. What you do is you pick one of these 5 answer choices and you put it back in the problem and see if it works. You pretend Michael has to be one of these 5 numbers. His age has to be one of these 5 numbers. So instead of solving the problem, why not just use one of the answer choices and see if it works? In the worst case scenario, this is trial and error. This is pure trial and error. In the worst case scenario, how many times will you end up trying? If you're sitting there and saying 5 or 4, you are wrong. In the worst case scenario, in the worst of the scenario, you will only have to try twice to locate the right answer. What you do is, you start with a happy medium. You start with the happy medium and you pretend Michael is 15 years old. You pretend that Michael is 15 years old. You put it back in the problem and see if it works. If it works, if it's fine, everything is hunky-dory. You're done. If all the pieces of the puzzle fit, you're fine. If it doesn't work, 9 out of 10 times, vast majority of the times, you should be able to tell if this number is too small or too large. If it turns out that it is too large, right off the bat you know that this is not the right answer. Neither is 20 nor is 25. It has to be either 10 or 12. You try one more time. It doesn't matter which one you pick. If you pick 10 and if it works, you're done. If you pick 10, it turns out 10 is too small, the answer is 12. Or if you start out with, if you in the second try you put in 12, if 12 works, you're fine. If 12 is still too large, then the answer is 10. In the worst case scenario, we'll only have to try it twice, which is what I'm going to do here. And then after we have done this back solving technique, if you're hell-bent on it, if you insist on it, we'll do it the proper way, the algebraic way, and you will be able to see the difference. You will be able to compare and contrast as to how much work is required in the classical method as opposed to this plugging in method. Do you understand? The difference between the plugging in method and the back solving method is that in the pure plugging in method that we do all the time, that you've seen me do all the time in the previous algebra problem, is where you make up numbers for the variable arbitrarily, any numbers that you want. Here, we do not just make up any old numbers. How old is Michael? I'm not going to pretend Michael is 350 years, because it has to be one of these 5 numbers. But essentially, it's the same idea. You make up a number for the variable, and you see if it works. Let's do it. Enough of the talk, let's do it. We're going to use back solving. Here are the 5 answer choices. And we're going to start with answer choice C. Answer choice C says, what number was this thing? 203. The very first problem, answer choice C says $3. The question was, the punchline, okay? The punchline is, let's erase this part, we don't need any of this. The punchline is where? If the price were to go up by $1, 10 fewer can be purchased. What was the punchline? I did not write down the punchline. What's the current price? There you go. What is the current price? Whatever they are asking here is what I refer to as a punchline. I'm not sure if punchline is to be hyphenated, but let's not worry about that right now. So we're going to pretend whatever they're asking, we're going to pretend that the answer to that question is C. Do you understand? Mumbo jumbo, mumbo jumbo, mumbo jumbo. What time is the sky going to fall? Answer choice C says 7:30 p.m. We're going to pretend that 7:30 p.m. the sky is going to fall. We're going to work with that time in the problem and see if it works. If it's too early, you try the later time. If it's too late, you try the earlier time. That's all it is. So let's pretend that the answer, current price is $3. We know that we are spending $120 total. If the current price is $3, we can buy 40 towels right now. 40 towels right now. When the price goes up by $1, it becomes $4. How many can you buy for $4 for $120? At $4 a piece, with $120, you can buy only 30 towels. Now, let's go back and see if it fits in the problem. See if the pieces fit. How many fewer towels are we buying? 10. How many does the problem say we are? How many fewer does the problem say we are buying? It says if the price were to go up by $1, 10 fewer can be purchased. Voila, bingo! We hit a jackpot in the first try. We just got lucky. But nothing to fret about. If we didn't get lucky, as I said, in most cases you'll be able to figure out whether to move up or down, and you try the higher or lower number and see if it works. In most cases you can tell if the number is too large or too small. Sometimes in the nature of the problem is that you cannot, but in most cases you can. Now I'm going to do the same problem in the algebraic manner, okay? Oh, these 2 words we learned in our vocabulary lessons. I do not know which day we learned these words. Abeyance means to leave something aside. We'll deal with it later. That's what it means. And brook means to tolerate something, to endure something, to handle something, to stomach something. As I said, I don't have my vocabulary list right now, so I cannot tell you which day of the vocabulary lessons we learned these words. But perhaps in the next video, if I remember it, I'll tell you. Let's solve it. So let's get going. Enough of the talk. So here's the classical way. I'm going to erase everything. We know the problem. I'm going to erase everything. We're going to start the classical solution. So we know that if you buy n towels and the price is $p, we're going to spend $120. When the price goes up by $1, instead of $p, if it becomes p plus 1, we can buy 10 fewer towels for the same amount of money, which is $120, which of course is the same as n times p. So that's our first equation there. So this quantity has to equal n times p. Let's open it up, shall we? Let's open it up. So p times n times p, minus 10p, plus n, minus 10 equals n times p, which can cancel out from both sides, and we end up with n. I'm not going to explain every step, I'm just going to do it. N equals 10 times p plus n equals 10 times, it says in my notes 10p plus, let's do the proper way here. I'm skipping step here, I'm getting confused myself. So n equals, bring the 10 to the other side, bring 10p to the other side, and it's 10 times 1 plus p, which is what I thought it should be. In my notes it says something else. I made a mistake in my notes here. So this is your n. Let's multiply both sides of this equation. Let's multiply both sides of this equation by p. Okay, stay with me in this story. Once we multiply both sides of the equation by p, here we end up with 10 times p, 1 plus p, which is same as 10p times 10p squared. And what do we get here on this side? This is n times p, p times n is same as n times p, which we know is 120. Which is going to go here. And there is our quadratic equation. All we have to do is solve this quadratic equation. Let's divide the entire equation by 10. So we end up with p squared plus p, bring the 120 to the other side, minus 12 equals 0. That's it. We're looking for two numbers, which when we add, we get positive 1, and when we multiply them, we get negative 12. When you think of two such factors of 12, the factors that we're looking at are going to be, since we need a positive one, it's going to be positive 4 and a negative 3. A positive 4 times a negative 3 gives us the negative 12 that we need, right here, the negative 12. And when we multiply them, positive 4 and negative 3 is going to give us negative 12 and a p squared. So it boils down to p squared plus p minus 12 equals 0, p squared plus 4p minus 3p minus 12 equals 0. If you look at this term and this term, we can take out p common. I'm not explaining everything here in too much detail because I'm assuming that if you're hell-bent on doing it the algebraic way, that you're fairly decent in algebra. And if you're not, then you have no business dealing with it. Just use the other technique. Take out the negative 3 common, and you end up with p plus 4. Look at this part now, and this part. What can we take out common? The common part is p plus 4. If you take out p plus 4, here we are left with p, and here we are left with negative 3. And that has to equal to 0. P plus 4 times p minus 3, p plus 4 times p minus 3 equals 0, which tells us that either p plus 4 is equal to 0 or p minus 3 is equal to 0, because their product is 0. If the product of two quantities is 0, one of the two quantities has to be 0, or maybe they are both zeros. In which case, p is either negative 4 or p is equal to positive 3. Obviously, p in our case cannot be negative 4 because we are talking about a price of something, and the price of something is not going to be negative $4, and therefore the answer is $3. That's all. This was the classical way. Now you decide and you pick which way you want to go. Alright? Bye now.